Hi, I'm Ali from Open Networking Lab. In this video, we're going to show you OpenVirteX. OpenVirteX is a network virtualization platform which allows you to specify your own topology and addressing while retaining control of your virtual OpenFlow network. In essence, we are introducing the concept of programmable virtual networks. Imagine a scenario where multiple enterprises would like to connect their remote sites. What if this could be done easily by spawning virtual networks which are embedded onto the physical network? Virtualization is essential here because it allows multiple tenants to specify how they want their resources to be connected independently from the service provider or infrastructure provider. Furthermore, supporting multiple virtual networks is becoming common in many settings, from data centers to service providers. There are several network virtualization solutions in the SDN space. Nicira, in particular, champion overlay-based network virtualization, which has now become the industry standard. In the meantime, Stanford introduced the concept of network slicing, using FlowVisor, which has become the de facto tool for researchers to slice and share the same physical network. We now introduce a new platform called OpenVirteX. With OpenVirteX, you can design your own topology, use your own network operating system to define the behavior of your network, use the entire address space usually available to you in a network. You can also start and stop parts of your network, as well as remove and add elements to your network. And finally, OpenVirteX can hide physical network failures from you, allowing you to focus on the exact desired behavior of your network. Wouldn't it be cool if these were available over a simple API call? Well, with OpenVirteX, they are. OpenVirteX sits in between OpenFlow switches and the network operating system. It speaks OpenFlow south to the switches and north to the network operating systems. Since OpenVirteX sits in the middle, it rewrites OpenFlow messages to perform isolation as well as the illusion of a virtual topology. In this demo, we will create isolated virtual networks, each with their own topology. Each virtual network is connected to its own network operating system, and finally, we demonstrate the resiliency features of OpenVirteX. Okay, so now we're going to show you OpenVirteX in action. Initially, we're going to spawn two virtual networks. So what you have here on the left-hand side of the UI is the physical network which the virtual networks are currently being embedded onto. Switches in the UI are depicted as circles, while the hosts are squares. The network depicts the Internet 2 infrastructure with campuses hanging off the major cities. The campuses at each city are of varying complexities, but both have aggregation and leaf switches. Now, the two virtual networks have booted. Let's have a look at the identical clone of the physical network. While it has the same topology as the physical network, notice that the DPIDs of the switches are different in the virtual and physical world. Let's have a look at a giant switch. This is a single giant switch which spans the entire country, abstracting away the complexity of the entire physical network. These topology configurations have significant implications on how your controller can interact with the network. We are now going to spawn the other three virtual networks. And we're going to see how OVX maps virtual elements onto the physical ones. We are going to use two virtual networks here. The first is a ring. This virtual network is a collection of giant virtual switches which are connected by virtual links. A virtual link is a link that spans multiple physical links. The second virtual network consists of three giant virtual switches abstracting the physical networks in the west, central, and east coast respectively. Let's choose the first virtual network. Now, let's start up some pings in a couple of virtual networks. We're going to drag lines between the hosts here. This starts up pings between the hosts. We start to see dotted paths showing the traffic flow through the network. Also notice how a path shows up in both the physical and virtual networks. Keep note of the IPs here because the same IP range will be used in the other virtual network. If you take a look at the hosts in this virtual network, you can see that they have the same IP addresses as the previous virtual network. This works fine because they are assigned unique IPs in the physical network. and OVX translates them into virtual ones before they get to the network operating system. Okay, let's take a look at a virtual switch. If we click on the switch, we see its flow entries put there by the tenant network operating system. This was populated by the ping traffic flowing through the switch. And now, if we click on the physical switch mapped to this one, we can see that it has entries in its flow table. These weren't added by the tenant. OpenVirtex actually translates the tenant flows so that every tenant's flows are isolated on the physical network. This way, the tenant only needs to care about his own virtual topology. Let's return to the giant switch virtual topology to demonstrate the resiliency features of OpenVirtex. We start by creating traffic flows between a few nodes. You can see traffic is starting to flow from left to right between the two node pairs. We now highlight how the flow in the virtual network is mapped onto a multi-hop path in the physical network. For instance, the flow between San Francisco and Cleveland uses a path that crosses the link between Los Angeles and Houston. We're now going to simulate a failure of this physical link. OpenVirtex detects this event and automatically switches over to a backup path. We can do this again by bringing down the link between Kansas and Chicago. And again, we see the traffic shifting away from the faulty link. OpenVirtex can do the switchover in a matter of milliseconds, and does it for all the virtual networks that are affected by the link failure. Here, we have only shown the resiliency features of OpenVirtex, but not its ability to stop and pause parts of the entire virtual network. Check out our tutorial to learn how to do these cool things. So we have shown you OpenVirtex, a network hypervisor, which allows you to create virtual networks of arbitrary topology and addressing. Moreover, you are still able to control this network via OpenFlow. In this video, we have seen that OVX enables multi-tenancy by implementing address virtualization. Then we have shown you that you can decide what your network looks like. Finally, we have shown that OVX can implement some resiliency features, thereby allowing your controller to be simpler. OpenVirtex is an open source project, so you're encouraged and welcome to contribute in any way. Welcome to the era of programmable virtual networks.